Welcome back, guys. So this is question 2.19 and the statement of this question is, the part A of it is find the current I1 and I2 in the circuit in figure P2.19. So this is figure P2.19. B is find the voltage, which is here. This is the voltage V0, and part C is verify that the total power developed equals the total power dissipated. Okay, so in order to do so, this is the circuit we have, and here we can see that this is the current source which is in parallel with this resistor, and here this resistor is in parallel with the series combination of these two resistors. You can see that this one and this one, the same current is flowing through them, so therefore these two are in series with each other. So therefore let me draw them. So in redrawing them, this is the current source, this is the resistor, or we can also draw the two series resistors as here it is. Okay, so this is the 100 ohm, this is 150, this is 250 ohm, this is the original current source which is of 1.5 amperes. So you can see that the current here is the I1, the current here is I2. Okay, as these two resistors are in series with each other, so therefore we can draw them like this is the source, this is the first resistor, and representing these two as the single resistor, we can add them together because in series the resistances have to be added together. So therefore 150 plus 250 is 400 ohm. Okay, this is 100 ohm, and the current source, the direction of it is here, this is 1.5 amperes. Okay, the polarity, the signs here are, this is the I1, this is I2. Okay, here we have this source current which is coming out of this, and this is I0. The value of I0 is 1.5 amperes, and the voltage V0 is here. Okay, so from this diagram we need to find out what we need to find all the values V0, I1, I2, and all those values. So from it, by using the Kirchhoff's current law, here we can see that this is the node, this current is coming towards it, and it is now split it into I1 and I2. So therefore I0 is equal to I1 plus I2. Okay, and also we know the value of I0, which is the source current, and that is 1.5 amperes. So therefore this I1 plus I2, that is equal to 1.5. let me call it equation A. Now similarly, as these two, this one and this one, these two are in parallel with each other, so therefore the voltages here between these two branches will remain the same. So therefore if the voltage across it is V1 and it is V2, so let me call it V1 is equal to V2. So the value of V1, if this is the V1, it will be I1 into 100 ohm, which is of this resistor, and V2 is I2 into what, 400. Okay, or simplifying it, we will get I1 is equal to 4I2. This is equation B, and also rearranging it, we will get I1 minus 4I2. This is equation C. Sorry, this is equal to 0. Okay, so now we have A, B, and C equations. Let me multiply equation A with 4 and then add A and C together. So multiplying this equation with 4, I will get 4I1 plus 4I2, that is equal to 6. Okay, and this equation is I1 minus 4I2 is equal to 0. Let me write it here as well. So this is I1 minus 4I2 is equal to 0. Let them add together. This will be cancelled out, and here we will get 5I1 is equal to 6, or the value of I1 is 6 by 5 amperes, and that is the answer for I1. Okay, let me take this value and put it into equation B. So putting it here, I will get this is the 4I2 is equal to I1. So putting the value of I1 here is 6 by 5. Okay, so the value of I2 will be equal to, that is 6 by 4 multiplied by 5, 6 by 20, which is 3 by 10. Okay, so this is 3 by 10 amperes, and this is for I2. In this way, we have solved part A of our question, in which the value of I1 is here, the value of I2 is here as well. Okay, so as these values are known, let us find the value of V0. As we can see that here, this branch, this branch, this branch, all these of threes are basically in parallel with each other. So therefore V1 is equal to V2 is equal to V0. Okay, so all these three voltages are same because all these three are in parallel with each other. So let me take any of these branches and apply the Ohm's law. So let me take this branch, okay, and let me apply the Ohm's law. This is part B. So V0 is equal to V1, and the value of V1 is I1 into 100, because of V is equal to IR. So the value of I1 is known, it is here, this is 6 by 5 into 100. So it will be here, this is 20 and 120 volts. This is the value for V0, which is the solution of part B. Similarly here, verify that the total power developed equals the total power dissipated. For it, let me move down somehow. Okay, so first of all, let me find out the power developed. So the power developed is across the source, which is here. So applying the rule here, which is P equal to IV, and here we need to find out the power which is developed. So the value of I is known, that is 1.5. Okay, and the value of voltage, which is V0 here, that is also known, and we have found it out. Okay, so let me write the value 120. Multiplying with it, we will get what? It will be 180 watts. Okay, so this is 180 watts. Now in order to find the power which is absorbed, so we have three absorbing components. The first one is here, the second one is 150, this is 250. Okay, so let me find the values of the power here. Okay, so the power which is dissipated across this one, so for it we have the formula, which is I square R or V square divided by R. We can use any one of them because the value of the voltage and current both are known, but as the current is already known and it is feasible for us to use the similar formula here, here and here, so let me use this one here. So I1 square into 100. Okay, so the value of I1 is 6 by 5 whole square multiplied by 100. Okay, so it will be 36 divided by 25 multiplied by 100. Okay, where did I get it from? So it is written here. So it will be 144 watts. Okay, so the value of P1 is known. Let me call it 2 P2. So the value of P2 is what? The value of P2 is I2 square into 150. Okay, and the value of P3 is here. So as these two are connected in series, so therefore I am taking them here as well as plus I2 square, because the same current is flowing through both of them. So it will be 250. Okay, so let me take this one out, so I2 square multiplied by 150 plus 250. So from here we will get P2 is equal to I2 square into 400. Okay, let me move down somehow to solve it. So now P2 is the value of I2 is known, and that is 3 by 10 whole square multiplied by 400. Okay, so it will be P2 is 9 divided by 100 multiplied by 400. So ultimately we will get 36 watts. Okay, so from it we have got that the total power which is dissipated, that is P1 plus P2. So 144 plus 36, that is equal to 180 watts. Okay, so from it we have got this 180 watts, and therefore we can see that this is the power developed while this is the dissipated power, and we can see that both of them are equal in values. Okay, so what we have done today, we have solved the question 2.19, and that is what we wanted to solve today. If you have any question, you can ask me in the comment box. See you soon.